So in this video we are going to examine the 6.5 geometric form of a complex number, and the example that we're going to start off with is going to be find the absolute value of negative 2 plus 5i. So you're going to have to find the absolute value of negative 2 plus 5i. Now the formula that we were given for the absolute value is we're going to have to use a formula. Now if you were to graph this, it would be actually helpful. So we learned that in Algebra 2 that absolute value imaginary is going to be a graph that looks something like this. And imaginary, this represents the y represents the imaginary axis, and this is still real axis. X represents the real axis. So this one, let's see where how we're gonna set this one up. So the way we're gonna do it is we're gonna say that z is given by a plus bi. So using our formula of an absolute value, we're going to just simply have to take an absolute value of the z value. So that means we're going to take a square root, square root of negative 2 square plus 5 square. I'll try to extend that right there. And then we're going to find the answer is going to be simply 4 plus 25, and absolute value of z is going to equal radical or square root of 29. So the distance from negative 2, the a represents the real number, and the bi represents the imaginary part, which is the I. Now this is part of the complex number, that's why the I is the complex number. And if you were to graph this, it's gonna look like negative 2 here. I'm gonna start with negative 2, and let's say this is 2 right there. Well, this looks like it's going to be at negative 2 and 5i. So looks like, let's make this right here. It's not drawn to scale, but 5i looks like it's going to be over here. 5i positive is going to be over here. So negative 2 and 5i is going to be right over here. Okay, and this is going to be the actual distance. Okay, so z negative 2 plus 5i is on that dot, and that distance of that right there is going to be radical 29. Okay, so we just kind of reviewed right now the complex numbers.